Okay, let's try again. All right, we've got 0 equals -2 minus 2 tangent theta. Okay, so we are trying to solve for the angle. When we're solving trigonometric equations, we're solving for the actual angle. So the angle in this case is theta, so that's what we're trying to solve for. So we're going to add 2 to both sides. And then we'll divide by -2, so we get tangent theta equals -1. So that means theta equals, let me be consistent here. We're going to do inverse tangent of both sides. So theta equals inverse tangent of 1. So that means when we think about our unit circle, we're trying to find where the tangent is -1. Tangent is y over x. So where is y over x -1? Well, this coordinate here is 1, 0. Okay, so on the axis, the tangent is either going to be 0 or it's going to be undefined. So it's not one of the axes. And that's one of the common mistakes. We have to be careful. Anytime it's on the axis, it's either 1 or -1. I'm going to say 1 or undefined, rather. Oh, my word. Can I speak? Anytime it's on the axis, tangent is either 0 or undefined. So where is tangent going to be 1? It's going to be at the 45-degree marks. So we're looking for y over x, and so they have to be opposite signs. So this one, we have -√2/2, +√2/2. So it would be here, which is 135 degrees, or down here, where we have a positive x and a negative y, which is 315 degrees. And we are working in degrees. Okay, we are specifically told to work with theta between 360 and 0. So that is our answer. Okay. Now, you can use your calculator to help you a little bit. You just have to be careful. You have to understand your calculator enough. Oh my goodness, Cole, your cough has not gotten any better. Yeah, wow. Weeks. It's been weeks. I'm sorry.
I've had this cough for longer than weeks.
Really?
Yeah.
What did the doctor say?
They said I don't have pneumonia. They said I don't have pneumonia. That's one possible.
Does your chest hurt with all the coughing?
Not really, no.
Okay, wow. Okay. So what we're gonna do is we're gonna use our calculator, okay? We're looking for the inverse tangent of -1. So when we do inverse tangent of -1 on my calculator, I have to make sure that Kobe, be quiet, please. I'm going to make sure that my mode is in degree mode, okay? And this is going to give me -45 degrees. Now, that's not how I want to write my answer, but it at least kind of guides me a little bit. -45 degrees would be going here. -45 degrees is the 315 degrees. So I've got to translate it into that. And then the other thing is, now I know that my reference angle is 45 degrees. So I check all of my 45-degree reference angles. So that's right here. This is 45 degrees. And this is 45 degrees. So now that I've got that reference angle, now I can check to see what other angles actually work. So your calculator can kind of give you a starting point, kind of a guide, but you have to understand the result that your calculator gives you. If you gave me -45 degrees, I would mark that wrong. Why would I mark that wrong? Well, because what's my domain here? Theta is between 0 and 360 degrees. Is negative 45 between 0 and 360? No, it's not. Okay. So although you can use your calculator to help, you can't just solely rely on it. Okay. Let's see. Number 2, we've got negative 3 minus 8 sine theta equals negative 7. All right, so I'm going to add 3 to both sides. We get negative 4. And then we'll divide by negative 8. So we get a positive 1/2. So theta equals inverse sine of 1/2. So again, I've got to look at my unit circle. Sine is that the x or the y? The y. So I'm looking for where the y is 1/2, and that's right here at 30 degrees. Okay, over here is the y positive or negative? The y is going to be positive, so 150 works. Okay, see what I'm doing? I've got the reference angle. Now I know it's 30 degrees now. So now I'm checking all of those. This one, the y is negative, so that doesn't work. And over here, the y is negative, so that doesn't work. So there's my answer. Okay, you have to know your unit circle. Okay, number 3, negative 2 minus cosine theta equals negative 2. So we're going to add 2 to both sides. And we get 0. And then dividing by negative 1, we still have 0. So cosine theta equals 0, which means theta equals inverse cosine of 0. So where is the x value equal to 0? 90 and 270. Good. 90 and 270. Okay. No, that has a whole different sound about it. That's a. His is a. So you see the difference? Okay. So what do we do on this one? Subtract 5 first. Subtract the 5 first. Good. And we get 0 and then multiply by 5. So sine theta equals 0. So here we get the same thing again. Theta equals the inverse sine of 0. It was the same thing, wasn't it? Oh, this was inverse cosine. Oops. So let's see, that's going to be here and here. Okay. So 180 degrees. So here we have to be careful. Do we want to represent this as 0 degrees or 360 degrees? 0 because of the way the domain is stated. This does not include the 360. Yes. And what do you? Oh, you're doing a high five. Oh. All right, number 5. Okay, so this is number 5. All right, so what do you want to do first? We could multiply. I would probably do that. We could subtract 2 and then get a common denominator. I chose to multiply everything by 4 first. If we subtracted 2, we'd have to get a common denominator, which would make this a 8 over 4, right? Which it means we'd have 8 plus root 2 minus 8 over 4. So we could do it that way. But I chose to multiply everything by 4 first. Okay. So I get 8 plus 4 times 1/2 is 2 cosine theta equals 8 plus root 2. Okay. Subtracting 8, we get 2 cosine theta equals square root of 2. Divide by 2, cosine theta equals root 2 over 2. So we're looking at theta equals inverse cosine of root 2 over 2. Okay, so the root 2 over 2, those are the 45-degree angles. So I'm only looking for where x is positive, so that would be here and here. So theta equals 45 degrees or 315 degrees. Okay? Okay, questions? How many of them got them all 5? How many of you got all 5 right? 4? Okay, good. Good. All right. Most of you got number 5 wrong. It got 4, right? Okay. Okay. So we are going to look at some more trigonometric equations, but this time, I don't know why she didn't leave me the worksheets. That's all right. This time, these are going to be quadratic, which means we have to factor before we can solve them. So I'm not going to do all of these. I'm going to do a couple with you, and then the rest you're going to do for homework. Okay. So let's look at number 1. Actually, wait a minute. Do I want to look at number 1? Oh, darn. I want to start with a little more simple before I do it.
Well, do you want us to do the second page of a worksheet?
Yes, problem is I don't have the second page because the substitute took them. I don't know where they are.
I can give you my copy and then use my iPad for it.
Let me see if I have it on here.
It was on Google.
Oh my goodness.
Yeah, number 7, so you can do mine.
But we only did one column.
Yeah. No, I did them first.
Okay, at first.
Okay, so let's look at the worksheet that you had for homework.
Sorry, I can't hear on my right ear either.
I'm going to look at number 9. We've got sine squared theta. Sine squared theta plus 3 sine theta minus 4. This is number 9. Okay. Number 9 on the worksheet you had over the weekend. The page that you were not supposed to do. Okay, everybody got it? Okay, so if we look at this, this is in the form of a quadratic. So if this was just x squared plus 3x minus 4, would you know how to solve that? How would you solve that? You'd factor it, right? Yeah, so we'd have x minus 1, x plus 4, right? And that means x minus 1 equals 0, so x equals 1. X minus x plus 4 equals 0, so x equals negative 4. Well, we're going to do the same thing, except instead of x, it's going to be sine. Okay, so we're going to factor this as sine theta minus 1 times sine theta plus 4 equals 0. We're factoring the same way we would if it was x's. It's just that instead of x, right, just kind of pretend that that's an x and pretend that that's an x. Okay. So now we're still going to use the zero product rule. So that means we're going to say sine theta minus 1 equals 0. Sine theta plus 4 equals 0. So that means sine theta equals 1. So theta equals the inverse sine of 1. And then on this side, we'll have sine theta equals negative 4. So theta equals the inverse sine of negative 4. Okay. So think about our unit circle. Right? Where is the sine value equal to 1? At 90. Okay, so this is 0, 1 here. Good. Anywhere else? Nope. So we get theta equals 90. How about where's the angle sine theta equal to negative 4? Nowhere. Lowest we go is negative 1, right? We can try it on our calculator because sometimes when we get stuck, that's what we end up doing, right? Inverse sine of negative 4. We should get an error message, and we do. We get an error because there is no place where it equals negative 4. Okay? So this is our answer right here. Okay, let's do another one. All right, let's look at number 10 on that worksheet. So we have cosine squared theta minus 2 cosine theta minus 3 equals 0. What do you think? It's quadratic.
It's cosine theta plus 1 times cosine theta minus 3.
Okay, cosine theta minus 3 cosine theta plus 1. Right? We're factoring it, and we're factoring it just like if it was x squared minus 2x minus 3 equals 0. We're factoring it the same way. That would factor as x minus 3, x plus 1. Okay? Now we use the zero product rule, and we're going to separate them. Cosine theta minus 3 equals 0. Cosine theta plus 1 equals 0. So we get cosine theta equals 3, which means theta equals inverse cosine of 3. So what does theta equal there? Nothing. Can't do it. We don't go over 1 or below negative 1, right? And then here we get cosine theta equals negative 1. So theta equals inverse cosine of negative 1. Everybody writing this down? Okay, so where's a cosine equal to negative 1? 180, good. Theta equals 180 degrees. Questions on it? Yes.
Once you have cosine equals negative 1, do you have to go to theta equals cosine?
You actually do. It's kind of a pain in the neck because, to be honest, this is where my brain works. I look at that, and that's where my brain works. But we're not solving for cosine theta. We're actually solving for theta. So I guess, you know what? If you go from this to this, that's okay as long as you have your answer as theta equals 180. I'll let you do that. Yes.
Now, if we have like the -3, do we have to bring that all the way down knowing that cosine does
No.
equal 3? So we
No.
don't really have to
You
write
could
all
you could
that.
stop right there.
Okay.
Okay. Okay. Yes.
Would we even have to switch it to cosine -3? Like, up there it's x minus the 3 and x plus 1. Why can't we just stop there?
What do you mean? I'm not
Like,
following you.
Instead of switching it to cosine theta plus 1 equals 0.
Well,
Why
we
can't we just,
leave it as x minus, because I'm not trying to solve for x. I'm trying to solve for theta.
well, it's just say it's
But it's not. I don't know what you mean. It's the same answer. So you want to? Am I just not understanding what you're saying? You want to do that?
pretty much, yeah. Because if you know theta is going to be at x, then it's always that.
The reasoning is the same. I feel like you're just being lazy and don't want to write it out.
Oh, yeah, 100%.
Yeah. So the answer is no.
Okay.
Yeah, we've got to write it out. This is just reminding you that it's following the same pattern. But what are we solving for? Okay. Okay, let's go back and look at number 7 now. Sine squared theta plus sine theta equals 0. Any thoughts on this one? Go. Take out a sine. And what's that leave me with, Emily? Sine, almost. Sine plus 1, yes. Okay. So, yes, I do want you to write everything out. I know it's extra writing and, it's kind of weird. Maybe you guys don't notice it. I notice it because I didn't grow up with computers, But like our hands get tired writing, don't they? We're so used to just typing on our computers. Like that's a strength and just an exercise that we don't have as much. Okay. Anyway, sine theta equals 0. Sine theta plus 1 equals 0. So here that means theta equals inverse sine of 0. And then over here I've got sine theta equals -1. So theta equals inverse sine of -1. Talking about writing, I was so lazy yesterday. I was floating in the swimming pool dictating my lesson plans instead of writing them. Is that lazy or what? My husband was just laughing at me. I'm saying this like Algebra 2, day 1, review worksheet. It was kind of nice actually. Yeah.
Like a speaker for like the microphone, just like speak into the microphone.
Well, that's what I was doing, but on my phone. Like I just had my phone on the little floaty, and I was just speaking into it. Yeah.
That's how you do it.
Yeah, I was dictating into it.
Shouldn't even write it. Just have your phone, and then like in the classroom, just like play the audio. Like yours.
Okay, so here we got sine theta equals 0. Where is the sine equal to 0? At 0 and 180, right? And then over here, where is it equal to -1? 270, good. So our answer is going to include all of that. So theta equals 0, 180, and 270 degrees.
Should we also include 360?
No, because oh, it does include it on this one. Oh, good observation. We have to include it. Yes. Because on this worksheet, it does include both 0 and 360. Yep. Okay. So We're not going to do the rest of that worksheet. Let me see if there's anything. Okay, let's go back to the one I just handed you. So these are a little bit harder. So for instance, look at number 1. We've got 2 plus cosine squared theta plus 3 cosine theta equals sine squared theta. So the reason that these are harder is because I've got both cosine and sine in this equation. Sometimes that's not a problem, but in this case it is. So if I subtract the sine squared from both sides, I've got a concern here, okay? Let me just show you where it's not a problem. So for instance, if we had one of the problems from the old worksheet from the weekend looked like this. In this case, it's not a problem having 2 trig functions. Does anybody see why? Well, because if I factor a cosine theta, I'm left with this. And then that means I can do cosine theta equals 0, tangent theta plus 1 equals 0, and I'm going to be able to solve both of those. On this one, I can't do that. I can't isolate my trig functions. So any ideas what I could do? What do we know about cosine squared or sine squared? They equal 1, yes. Sine squared is one of my Pythagorean identities. Remember, sine squared theta plus cosine squared theta equals 1. That's one of my identities. So that means that sine squared theta is equal to 1 minus cosine squared theta. So I'm going to substitute this in for sine squared. So I have 2 plus cosine squared theta minus, instead of sine squared, I'm going to do 1 minus cosine squared theta plus 3 cosine theta. Now I've got everything in terms of cosine. So we have 2 minus 1 plus cosine squared theta. And I'm going to distribute this minus, so that's plus cosine squared theta again, plus 3 cosine theta. So let's see. I have 2 cosine squared theta plus 3 cosine theta plus 1 equals 0. Now I have to factor. So let's see, 2, 1, 1, 1. That's going to factor correctly. That gives me 2 plus 1 is 3. So that's going to factor as 2 cosine theta plus 1 times 1 cosine theta plus 1 equals 0. Again, you can factor if you have different ways. There's lots of different ways to factor. This is the method that I use. Okay, so now we have 2 cosine theta plus 1 equals 0. So 2 cosine theta equals negative 1. That means cosine theta equals negative 1/2. So theta equals the inverse cosine of negative 1/2. Okay, and I'm going to work with the other one. Cosine theta plus 1 equals 0. So cosine theta equals negative 1, which means theta equals inverse cosine of negative 1. Okay, so let's check our unit circle. Okay, where does the cosine equal negative 1/2? Well, the 1/2 cosine, where x is 1/2, that's up here at the 60-degree angles. Okay, so here it's positive, so that's not correct. So this one, and that is which angle? 120. And then down here at 240. Okay, and then where is cosine equal to negative 1? At 180. And that's our answer. Okay. So let's see. So number 2 is going to be the same type. You're going to have to use your Pythagorean identities. Number 3. Number 4 is not. That's a straightforward one. So a lot of these you're going to have to use your Pythagorean identity. Okay. Any questions on the one we just did? Okay. I'd like you to finish this worksheet for homework. This will be tomorrow morning by 8 a.m.